Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we're working on the August 2016 New York Geometry Common Core Regents, problem number 7. If you want to access these exams, they're freely available online. Go to nysedregents.org and click on the appropriate tabs. So here's the problem. Quadrilateral ABCD with diagonals AC and BD is shown in the diagram below. I do look at the diagram, okay? AC, BD. And I don't analyze it much more than that. Now, which information is not enough to prove ABCD is a parallelogram? Okay, so is a parallelogram. Let's see, AB congruent to CD and AB parallel to CD, AB congruent to CD and BC congruent to DA, AB congruent to CD and BC parallel to AD, or AB parallel to DC and BC parallel to AD. I strongly advise you, pause the video right now, see if you get the same answer that we do. If you do, definitely hit the like button. So this is how we go about doing it. It does help in this case to know the definition of parallel, to know the definition of a parallelogram. So a parallelogram is a quadrilateral with two pairs of parallel sides. Okay, so in this case, we'd need this parallel to this, and then also this parallel to this. Now, that's the definition, but it does turn out that there's some equivalent statements that can be said about parallelogram. In other words, a quadrilateral is a parallelogram if and only if certain individual statements hold. So let's see if we have some of these here. So number 1 says that AB parallel to CD, congruent to CD, which, let's see, this is congruent to this, which is okay. And also AB is parallel to CD or DC. In this case, there is an equivalent statement about parallelograms that a parallelogram, if it is a quadrilateral, is a parallelogram if and only if one pair of sides is both parallel and congruent. And in this case, one pair of sides is both parallel and congruent. So that is enough. We need not enough. So this is not the answer. Number 2, AB is congruent to CD. Let's see, AB congruent to CD. We'll keep that marked. We'll erase these other markings that we have so far. So AB congruent to CD. Let's go in red now. AB is congruent to CD. Okay, and BC is congruent to DA. Okay, so there's another equivalent definition, if and only if two pairs of sides are congruent. So if two pairs of sides are congruent, then the thing's a quadrilateral parallelogram, and all the statements about parallelograms are automatically true. This is enough to show that this quadrilateral is a parallelogram. So that is not the answer. Let's go for the black pen, and let's see. AB is congruent to CD. Let's erase these marks that we have so far. AB is congruent to CD. Boom. Here and BC is parallel to DAD. So this is one pair of sides congruent and then a different pair of sides parallel. That's a little tough. You might not see why that might not be the case, but I'm not. Let's suppose that I'm iffy on that. So let me go on to number 4 and see that if I can justify number 4. So, and I'll put a question mark on number 3, and let's go for the green pen, and then AB is parallel to DC. Okay, and then let's see, BC is parallel to AD. In fact, this was the definition of a parallelogram. Quadrilateral with two pairs of parallel sides congruent. So this is the definition. And so, in fact, this is enough to show that the quadrilateral is a parallelogram. So it does, in fact, have to be choice 3. So now maybe we can establish why it should be choice 3, independent of the other ones. So now it's tough to see why this might be the case. But see, now by saying that BC is parallel to AD, okay, all we're saying is that these two sides are parallel. They're contained in parallel lines. Okay. And this one's contained. They're contained in parallel lines. We don't know the lengths. We don't know how long they are. We just know that they're contained in certain parallel lines. Now, the first part says that AB is congruent to CD. Now, it might not be easy why that might not be enough. It might not be easy to see, but it might help to see like this angle is not a right angle. So it could be, what if we open this up, this angle up? So right now this angle is congruent to this, but what if we opened up this angle over here a little bit more so that this side went to here? And now we have a different side, B prime. And this is congruent to this. And now B prime C is parallel to AD, and also B prime is congruent to CD, which satisfies the conditions for 3, but in fact this B prime CD is not a parallelogram. So this in fact is not enough to show that this object is a parallelogram. What this does show, this statement, BC parallel to AD, implies that ABCD is a trapezoid. Okay. And then the statement that AB is congruent to CD implies that ABCD is in fact an isosceles. And it's 2 words, an isosceles trapezoid. And that's all it tells you. Okay, so that's it. Let's see if we can get an extra problem in. If that's all you needed, then definitely hit the like button and go on to the next video. But we did create an extra problem for you to practice on. Definitely recommend pausing the video once again and try it on your own. A parallelogram ABCD with now we know it's a parallelogram with diagonals AC and BD is shown in the diagram below. Which of the following is not necessarily true? AC congruent to BD, AB equals CD, AD equals BC, and angle ABC is congruent to angle CDA. Definitely pause the video, try it on your own, see if you get the same answer, and if you do, definitely hit the like button. And by the way, we do appreciate your subscription. It helps us to be able to take more powers with the channel, to open up the channel to more people to be able to advertise. So definitely hit the subscribe button. It'll definitely help us out. And we provide these videos for free for students like you, because we want to help students who have access to videos in a free fashion. So when we are providing tutorials in algebra, geometry, algebra 2, trigonometry, biochem, and physics, and more to come as well. So keep an eye out for those. And this is in geometry, so when you get to algebra 2, you'll have videos in that as well. Okay, so now which of the following is not necessarily true? Let's see if we can determine it. Hopefully you did pause the screen and tried it on your own. Let's see. We know what a parallelogram is. We know all the properties that they have to hold. That 2 pairs of parallel sides congruent, 2 pairs of parallel sides, and I'm going to give you all the properties that parallelograms hold that are tested on this test. 2 pairs of congruent sides, So if any of these statements hold, then the object is a parallelogram, and if the object is a parallelogram, then all of these statements hold. But only one of these has to hold for the object to be proven to be a parallelogram. One pair of opposite sides is both parallel and congruent. Okay, the next one is the one that we didn't discuss before, that two pairs of opposite angles are congruent. And then finally, this is a cool one, a very useful one for a lot of geometric proofs, especially those 6-point problems, that the diagonals bisect each other. That's it. That's really all they test for. There are other statements you could probably come up with, but that's about it. So let's see, which is not necessarily true. AC is congruent to BD. Already, AC is congruent to BD. The diagonals are congruent. Well, they don't really look congruent. They don't even look. This looks like a parallelogram, so I'm going to assume this diagram is drawn to scale. It's very hard to draw a parallelogram not to scale. It's just two pairs of parallel sides. So the fact that the diagonals don't look like they're congruent seems to imply that this is not it. And in fact, it's not. There's no restriction on the length of the diagonals. One could be 1 centimeter long, one could be 1 billion centimeters long. That would be an extreme parallelogram, but it could be true. Now, AB, I'm sorry, so that is the answer, because we're not necessarily true. Okay, so AB, we're just going to check our answer. AB congruent to CD, in fact, two pairs of opposite sides are congruent. Two pairs of opposite sides opposite sides are congruent. Okay, so that was just a little error. If you catch any errors, definitely let me know in the comments. AB equals CD, that's true, because they're congruent. Now, AD is congruent to BC. Again, that's the opposite sides are congruent. And then angle ABC is congruent to angle CDA, and that's, well, both pairs of opposite angles are congruent. So that is true, and we want not necessarily true. So in fact, 1 is the answer. All right, hopefully this helped. Definitely hit the like button if this did help you. Subscribe. We have a lot more videos coming. So thanks for watching it, and stay tuned for the next video starting right now.